The new identities we're going to talk about in this section are called sum and difference identities. And those come from the fact that if you take a look at the first one, what you have is cosine of alpha plus beta, sine of alpha plus beta, or you have cosine of alpha minus beta. So basically you're taking sine and cosine and tangent of two angles added or subtracted to or from each other. Okay? This is the one. So the book lists them with cosine first and then sine, but if you write them as sine alpha plus beta, right? And then, so that's sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And then take a look at the cosine. Cosine of alpha plus beta is cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So now, if you write them in this order, then, if you write sine first and then cosine, then it's a sum. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? And that's one way you can remember it. There is no song for tangent. Okay.
Did you make that song up?
I did not. It's a thing. Sine, cosine, cosine, sine, cosine, cosine, sine, sine.
The difference identities.
So you don't
just change.
Huh?
You don't include like the
Okay, so now.
Wait, for the difference identities, the only difference is you change.
Okay, so let me talk about that. Now, the more concise way of writing it is, if it was sine of alpha minus beta, if there was a minus there, then there would be a minus here. The cosine is the opposite. If there was a minus here, then there was a plus there. So if you look for the sine, a plus stays as a plus, the minus remains a minus. The cosine will switch. If it starts with a plus, then it's a minus. Minus will switch to a plus. Tangent looks complicated, but if you look a little bit more closely, you'll see that it's not very difficult to remember. So if you have tangent of alpha plus beta, it's as if you distribute it. So you take tangent of the first and tangent of the second. We don't really distribute tangent, that's not a thing. But you know, it's as if you did that, gave a tangent to each of these. And then on the bottom, it's tangent A, tangent B. So if it's a plus here, plus on top, minus on the bottom. If it's a minus here, minus on top, plus on the bottom. So these are ones that we're just gonna memorize. Okay, why do we need these? We know how to find sine, cosine, tangent of the special angles and the quadrantal angles, a 60, a 225, a 5 pi over 6. But not for the 75, not for the 7 pi over 12. So that means, do we just need a calculator for them? No. We can write our angles sometimes as a sum or a difference of two angles from the unit circle. So for example, sine of 75 can be written as sine of 30 and 45. Now you could also say, okay, it's 20 and 55, but those are useless angles as well. You want to write them in terms of angles off of the unit circle. So 30 plus 45. Now when you have the sum and the difference, then you can apply the identity. So this is sine, cosine, cosine, sine. So it's going to be sine of the first, cosine of the second, plus cosine, sine.
What would happen if you switched around?
So in the end, you're taking the sine and the cosine of each of them, right? So you're taking the sine of 30 and the cosine of, now, if you switched, like if you did cosine 30, sine 45, and then sine 30, as long as like if the sign is correct, S-I-G-N, then okay, but there are some switches that are not okay, all right? So now this is why we need to know these quickly. We need to be able to do these quickly. Sine of 30, 1/2. Cosine of 45, root 2 over 2, plus cosine of 30 and sine of 45. So with the 30 and the 60, right? If sine is 1/2, then cosine has to be the other one. If sine is root 3 over 2, then the cosine of it is just going to be the other one. So it's almost automatic. So now I have root 2 over 4 plus root 6 over 4, which I then combine and do root 2 plus root 6 over 4. Okay? And those of you who've seen this in Algebra 2, I know some of you, most of you have, you'll remember that they were just like the same numbers but switched around most of the time. Okay? All right. Now, sine of negative 7 pi over 12. First off, let's remember that sine of negative theta is what? Negative sine theta. So I can easily write this as negative sine of 7 pi over 12. Okay? Now, I need to rewrite the 7 pi over 12 as a sum or a difference of two angles. And here's the easiest way that I've figured out to do this. It's going to be over 12 and over 12. It's plus. I do have a plus there. So it's going to be over 12 and over 12. Now, you need to put numerators there that will reduce to angles off of the unit circle. So for example, how do you get 7 pi? You can get 7 pi by 1 and 6, but pi over 12 is not one of the angles on the unit circle, so that's not going to work. You see what I mean? So you could do 2 and 5, but 5 pi over 12 doesn't work. 3 and 4, if you do 3 pi and 4 pi, those reduce to pi over 4 and pi over 3, and that's totally off of the unit circle, so you can do that. Okay? So now, this is negative sine pi over 4 plus pi over 3. This is negative. Okay, and now we're going to do our expansion, right? The identity. So sine of the first, cosine, and then plus cosine, sine.
I don't understand why you explain it like that. Can you explain that?
This last step?
Yeah.
Well, that's the identity. When you have sine of an angle plus another angle, you got to use the identity, the sum identity that we just learned.
You can't do it without it?
No. You can't do it without it, not without a calculator. There is no other way. If you come up with a way, maybe we can give you the Nobel Prize.
Wait, so you're telling me that, like, for example, sine of 75 degrees isn't the same as, sine of 30 just plus sine of 45?
No.
It's not?
It's not. Do it.
That's
Yeah.
Does it matter the order? Like if you do
So if you did sine of pi over, if you did sine of pi over 3, cosine of pi over 4. I mean, it depends. Like if you did cosine pi over 3, then sine of pi over 4, no, it doesn't matter.
Okay.
Yeah. So this is negative. All right, sine of pi over 4 is root 2 over 2. Cosine of pi over 3, 1/2. Plus cosine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. So now this is negative root 2 over 4 plus root 6 over 4. And then let's combine that to negative root 2 minus root 6 over 4. All right? Okay, so you'll see, again, it's root 2, root 6, 4, and then the signs are different. All right?
Doesn't matter what the order is?
If you got negative root 6 minus root 2 over 4, no, it doesn't matter.
Can you make a fraction negative and root 2?
Fine. Okay, so here, take a look at this problem. Here, what we are given is the expanded form. All right, and we're going to go backwards. So we're given an expanded form, and we have to go backwards. So basically, when you see tangent something minus tangent something else, tangent of alpha minus tangent of beta, 1 plus tangent alpha tangent beta, Hey, where have we seen that before? Right there in that identity, right? So take a look here. Tangent alpha minus tangent beta, right? That's what I have here. And then 1 plus tangent alpha tangent beta. So then this means I'm going backwards. So this whole thing is equal to tangent of alpha minus beta, which in this case is tangent of 78 minus 18, which is tangent of 60, which is how much these days? Root 3. Okay? Now, can you skip this step? Yeah. Okay? All right. Look at this next one. I have cosine of some angle, cosine of another angle, sine of the first angle, cosine of the second angle. Oh my gosh, that's cosine, cosine, sine, sine. Where have I seen that before? Well, here. Okay? Cosine, cosine, sine, sine with a plus in the middle. So this is going to be cosine of alpha minus beta, cosine 7 pi over 8 minus 5 pi over 24. How much is that? Cosine, cosine, sine, sine is it changes sign. So take a look here.
Oh, okay.
Cosine, cosine, sine, sine, it alternates sign. So how much is this one? 2 pi over 3. And cosine of 2 pi over 3 is 1/2. Negative 1/2. Okay? All right. 7 pi over 8 minus 5 pi over 4, common denominator. Yes? Okay. All right, so next one. Ooh, my favorite ones. All right? My favorite ones. So take a look at what I have here. Cosine of something plus something else. So cosine of alpha plus beta, except alpha is that entire thing and beta is that entire thing. So if I have cosine alpha plus beta, that's cosine, cosine, sine, sine. So I got to do cosine of alpha, which is this mess, right? Cosine, cosine, sine, sine. And then cosine of beta minus sine and sine. Some things will simplify now. So if we go through, cosine and arc cosine of x just give us x. Sine, arc sine of root 3 over 2 is just root 3 over 2. Okay, let's take a look here. I have cosine of arc sine of root 3 over 2. Basically, I have an angle, the sine of which is root 3 over 2. What's the cosine of it?
1/2.
1/2. So if the sine of an angle is root 3 over 2, I don't even care what the angle is. Okay, it's 60. But if the sine of an angle is root 3 over 2, the cosine is 1/2. Right? Yes?
How do you simplify? I don't get what you said.
Cosine and arc cosine cancel each other out, so you just get x. Sine and arc sine cancel each other out, so you just get root 3 over 2. And over there, the cosine of the arc sine of root 3 over 2 is 1/2. So that's just, you know, a long way of saying the sine is root 3 over 2. The cosine must be 1/2. Here, I got to draw a triangle. This is the reason why we did it on the homework in chapter 4. It was on a test in chapter 4. So I have an angle, theta, the cosine of which is x over 1. So the sine is, so the opposite side is how much?
1 minus
1 minus x squared. Okay? So the sign there is the square root of 1 minus x squared all over 1. Okay? So now let's put all this together. No. I have 1/2 times x minus root 3 over 2 times 1 minus x squared in the root. When I combine the fractions, they all have a denominator of 2. On top, I have x minus root times root. We multiply the insides, so it's the square root of 3 times 1 minus x squared. Can you distribute so it's the square root of 3 minus 3x squared? Knock yourself out. Okay? Either way. Either or.
Why can't you find sine arc cosine? So you can find cosine arc sine. Yeah, you got it.
Because it's sine arc cosine of x. Yeah, it's not a number. Okay, here's one more. Sine alpha minus beta. So now it's sine, cosine, cosine, sine. All right, so let's do this one. This is sine arctan x cosine arc cosine a half minus or plus? Minus sine cosine. Okay, so cosine arctangent of x sine arc cosine of a half. All right, so let's see what we can cancel here. Cosine arc cosine of a half is just a half. Okay, now look at this. The very last one. With 3 over 2? Yes? Yes. If the cosine of an angle is 1/2, the sine must be a root 3 over 2. Awesome. That's how quick I want that to be. Now, here I have arctan x, arctan x. Let's draw a triangle here this time. We're going to use it for both of them, actually. I have an angle, the tangent of which is x. And then the hypotenuse is the square root of what? Yeah, x squared plus 1. Okay? Now, so for this first one,
Can't you take that out of the root?
no, because roots don't distribute like that. Okay? Roots don't distribute. You can't do the square root of x squared and the square root of 1.
Okay.
So this one here, we want the sine. It's x over the square root of x squared plus 1. And then I want the cosine, and that's just 1 over the square root of x squared plus 1. So let's put it all together. I have x over 2 times the square root of x squared plus 1 minus root 3 over 2 times, yeah, okay. So you see the denominators are the same? So I can just combine them?
Are they always going to be the same?
No, unfortunately not. Now, in another life, so this is what we get here. In another life, we would have had to rationalize the denominator, and it's so much fun, but we'll forego that one now. Okay?
Why'd you take the 3 out of it?
Oh, I did not. I meant not to. I didn't mean to. Okay. Okay. Now, in section 1, I just threw this at you, and I said, oh, by the way, cosine of negative theta is cosine of theta. Now, we did reason through it a little bit. But now let's prove it. Let's prove it mathematically, okay? Cosine of negative theta, is it really equal to cosine of theta? Let's just see it. So the way we do these verifying, this is what you do in this is all you do in section 2. So I took out section 2, but there are, little ones that we're going to do throughout these 2 sections. Okay, now, so this is cosine of negative theta. Now, what's another way to write a negative number? Like if you want to write -3, is it the same as saying 0 minus 3? It is. So why don't we write 0 minus theta here? Because it's the same. And you have an equal sign. So the trick with these, with verifying is, you know, we want to make these equal signs line up like this. So here I have cosine of alpha minus beta. Cosine, cosine, sine, sine. So cosine 0 cosine theta plus sine 0 sine theta. Now, what's cosine of 0? You guys know. 1 times cosine of theta plus what's sine of 0? 0 times sine of theta. What's 0 times anything? 0. So I have 1 times cosine of theta, which is cosine of theta, and sure enough, that equals cosine of theta. So do you see where it comes from? Okay? Yeah. Okay, so that's that. Okay, let's do this next one. Because that's another way to write negative theta. What we do is we write it in a way that is appropriate for us to use an identity, a sum and difference identity. All right? Now this next one, cosine of theta minus pi over 2, that's already in that form. So now this is the cosine, so let's just do this one. Cosine theta, cosine pi over 2, plus sine theta, sine pi over 2. Cosine switches. What's cosine of pi over 2 these days? 0. What's sine of pi over 2? 1. So what are we going to end up with here? Sine of theta equals sine of theta. All right? So again, we just verified. Isn't that cool? I could do them all day. Right? Now, take a look at this next one. I have cosine alpha plus beta. I have sine alpha minus beta. It's like two identities in one problem. So let's divide and conquer. Let's do the one in purple first. Cosine, cosine, sine, sine. Cosine, cosine, minus sine, sine. There is a minus there, and then we got to put parentheses. Please don't forget that. It's make or break, okay? And now I have sine, cosine, minus or plus, minus cosine, sine. And that equals 0. Okay, let's see what we could do here. What's cosine of pi? -1. What's sine of pi? Love those zeros, right? What's cosine of pi? Still -1. What's sine of pi? Still 0. Okay, so now here we got to be a little careful. So what I have in here, I have negative cosine of x. The next term went away. Now this term, negative or positive? Positive sine of x is equal to 0. Oh my, what now? Yeah. Last lesson.
Oh, you're just adding both of the signs?
So here's another way of taking a look at doing this. Why don't we, just for fun, add cosine of x to both sides? Okay? What does that give me? Oh my. Why? For what angle is the sine and cosine the same? Pi over 4. Isn't that cool? Come on, tell me that's not cool.
So cool.
Huh? Yeah, it is pretty mind-blowing.
No.
What about at pi over 4? 5 pi over 4.
Still.
Still, everywhere, right?
Not everywhere. If it's in quadrant 2 or quadrant 4, then we're going.
Right. What about at 3 pi over 4?
No.
Nope.
Then cosine is negative.
What about at 7 pi over 4?
No.
No. Okay, so in the first quadrant, sine and cosine are both positive. In the third quadrant, sine and cosine are both negative. In the second quadrant, sine is positive, cosine is negative, so that does not work, and it does not work there either. All right, so it works in the first and the third quadrant. No? Yes? No?
Yes.
Okay. So now, last one. Okay. I'm a little excited about that one. This next one is straight out of calculus. And we get to do it in chapter 12 in here, actually. Yeah.
On example number 7, wouldn't the signs cancel out though?
I don't see where.
Well, if it's -1 sine x and then you add another negative.
So this one says to expand the formula for the difference quotient. And again, this is one that's straight out of calculus, but we're gonna visit this. We're gonna do it at length in chapter 12, like in May. So basically, we have to expand this for the function that we're given, and that's that. So usually to do this, you're given a function, f of x equals x, f of x equals the square root of x, f of x equals sine x, f of x equals cosine x. And we have to build this function. So this function says f of x is equal to f of x plus h minus f of x over h. And now we have to build the different parts of this. What we're given to use for f of x is cosine. Okay? Now, let's try to build some of the other ones. So, let's do a little bit of exploring here. F of x is cosine of x. Now, if I wanted to do f of 1, that would be what? Cosine of 1, right? What about f of a? Cosine of a. So basically, I'm replacing x with whatever is inside those parentheses. So now, if I had to do f of x plus h, what would it be? Awesome. Okay, so we're going to use that. Okay, now, so here,
Wait, what do you mean you're going to use that?
we're going to use that in here. So now look, I'm being asked in this one for f of x plus h. Well, what was f of x plus h? It's cosine of x plus h. Yeah. I do my parentheses later. Minus f of x. What's the f of x I'm given? Cosine of x over h. Okay? Now, does anybody see anywhere that we can apply an identity? Well, the green one, right, that's an identity. It's cosine of alpha plus beta. So it's cosine, cosine, sine, sine. We never distribute. We apply identities, okay? So this is going to be cosine, cosine, minus, as I just heard, sine, sine, minus cosine of x over h. For now, and it's actually kind of disappointing for me. For now, we just leave it the way it is. It's disappointing for me because where we go after this is so exciting, but we can't do that yet until chapter 12, okay? So we are gonna come back to this form, okay? Basically with this, we can figure out how to find expressions of the slope for every single function. Okay? All right. So that's where we're going to end here. This is going to be due when we return. What period is this? G? So
We have class Monday.
we have class Monday, but I will make this due officially the following class. All right?